please begin.
Thank you so much, Anne. You guys hear me well? All right. So welcome to this Khronos talk about OpenXR's open source pipeline for accessible XR development. Pretty long title, but we'll get there. So today we'll dive into how Khronos has been supporting developers in creating and crafting amazing open and immersive experiences. So I've already been introduced, but really quickly, been with Collabora for 15 years, started as a freelance consultant software engineer, and I'm now leading the XR division. I've also been involved with Khronos for a few years now, and currently acting as the OpenXR Vice Outreach Officer, where I can spread the word about OpenXR in the various communities. So it's with my Khronos hat on that I'm going to give that talk today. So let's jump right in. But before we do so, for those of you who might be new to Khronos and OpenXR, so just a quick overview. So the Khronos Group is an industry consortium, nonprofit that create open and royalty-free APIs to basically let development of applications that are hardware accelerated and platform agnostic. And what is OpenXR? Of course, it's like the key to creating AR, VR, and XR apps in a seamless way. So think of it as being this very handy cross-platform toolkit for making sure that your XR applications just run seamlessly on various platforms and devices without requiring a ton of tweaks. Our goal with OpenXR is to enable developers to tap into hardware powers without getting stuck in one development environment or one XR ecosystem. But at the same time, it's to provide a nice API for platform developers, a nice set of API to make sure that their users have a seamless, repeatable, and smooth experience no matter what device they're on. And so, why is OpenXR important, especially for developers, right? I'm just going to break it down to a before-after comparison. So before OpenXR, XR apps and game engines had to juggle different codes for all of the platforms and devices that they wanted to support. Rather complicated, whereas now with OpenXR, it's like having this unique universal language that connects apps and all of the OpenXR compliant devices and platform in a seamless way, right? This means less coding hassle, and easier maintenance, and usually future-ready compatibility, even with upcoming devices that don't exist right now. And so if you haven't already jumped on the OpenXR train, I think now is a pretty good time to do so. I mean, take a look at that list of already supported devices. It's crazy. I mean, not only OpenXR API is already supported by the vast majority, I'm having trouble with that, the vast majority of XR headsets and runtimes today. It also includes 3D stereoscopic displays, AR glasses, very famous OpenXR SDKs and runtimes, as well as most of the most popular game engines, WebXR-enabled browsers, and XR libraries and simulators, as well as this guy here that we're going to be taking a look at a little bit later today. If you don't mind, let's just take a quick trip down memory lane just to remember what happened. So about OpenXR. So the OpenXR Working Group was born in 2017 with a very tough mission. So to end the chaos of vendor fragmentation, for vendor API fragmentation. And it literally took 20 companies grinding for 2 years to bring OpenXR 1.0 to life in July 2019 at SIGGRAPH. And this very important milestone gave us OpenXR functionality, but also an extension mechanism, right? And at the time, we also saw the first 2 OpenXR compliant runtimes, which are Microsoft's Windows MR and Collabora's Monado. This extension mechanism works so well after launch that fast forward to today, a bit less than 5 years later, we have a whopping 146 OpenXR extensions into the specs. And so that is one of the reasons why we released, and we worked so hard on releasing OpenXR 1.1 just in April this year, right? Of course, this release is packed with a lot of feature enhancements, but more importantly, it kicks off the very important process of consolidating the mature extensions back into the spec, right? In order to solve that initial problem. And so all that being said, let's take a look at some very interesting stuff that we've been up to lately. So the Khronos Group very recently funded the enhancement of two already existing very interesting open source projects, namely the Monado. Sorry, I'm using the wrong button. Namely the Monado XR runtime with the Monado upgrade project that was funded last year in September, and the Godot Engine project with the Godot integration project that just really started like a week ago. And the goals with those two were to lower the barriers to entry for developers, encourage, of course, a more widespread adoption of OpenXR, but also invigorate the open source XR ecosystems. I really think with those two initiatives, Khronos really doubled on creating a welcoming and innovative space for app developers. And we're going to take a look at what those two projects are all about today. So let's take a moment to discuss Godot. So Godot is this fantastic open source game engine that's getting a lot of traction these days in the community. It is leading the pack of free and open source game engines, and it's very popular with independent studios. So not only is Godot open source, it's also very feature-rich, providing comprehensive development environment for creating 2D, 3D, and XR games and apps. It's got a wide range of tools, ranging from visual scripting, of course, to physics engine, animation support, and it's also got a nice set of exports templates to let you guys export your OpenXR applications to a very nice array of devices on Windows, Linux, and Android. It's also got a strong community contributing plugins, extensions, and tutorials to make Godot an even better engine. So you can check out their Discord. There's tons of information out there for you guys. What about Monado now? Monado is a cross-platform, open source OpenXR runtime maintained by Collabora. It aims to provide like a universal platform for XR. It runs on Linux, Windows, and Android, and also got a strong community. So you can check out our Discord. You're going to find a lot of information about those three platforms and a lot more. Like all the Monado drivers, we have channels for that. And for developers, Monado has got this nice simulated HMD, which is very handy at prototyping phase, right? Simulated HMD is like this very handy prototyping simulator that lets developers build, create, and test OpenXR apps without requiring any hardware. It usually means faster iteration cycles, so usually lower barrier to entry just to test new ideas, right? And for XR platform makers, Monado is really interesting because it's like a very robust foundation for enabling OpenXR on new hardware or exotic hardware, right? Its open source nature lets you extend and customize it the way you need on your platform, and it usually means reduced time to market. So we'll take a look at that diagram now. It's like depicting a typical prototyping, testing, and deploying workflow with Godot. But in this case, you see Monado on the left is being used as an XR simulator. So it runs on your favorite OS, does not require any hardware. It's especially suitable for prototyping, right? Eventually, you'd like to run on specific hardwares, but for this phase, it's rather handy. A note here that the macOS platform support right now is experimental, not part of the Monado main tree. But as we're seeing like a growing interest for that platform, it's not excluded that Collabora spends some cycles on that this year. Don't want to commit to anything, but it's a possibility that we give that some love. You can hear in that workflow on the left, you can, for example, use Monado's QWERTY driver very easily to change the head and controller pauses in your application, or change the user's XYZ location just using the keyboard and mouse, right? Using the Monado's remote driver, you can easily create a remote debugging device that will be able to pilot your XR session from the outside and do some more advanced stuff. Now on the right, once you're ready to export your OpenXR apps, you just take a look at this list of supported devices. It's basically everything. That's OpenXR, right? You basically get for free like all of the OpenXR compliant devices. Although Godot being an open source project, there's some rough edges, of course. For example, in this list, the X-Real glasses for Godot 4 hasn't really been tested yet. There's a notable platform missing in that list, which is HoloLens. HoloLens was working Godot 3 because they got a special OS, and some bits aren't yet ported to Godot 4. So you see it's a work in progress. We'll see at the end of the presentation how you can contribute to all this and make that and perfect the support. But yeah. We will now take a look at how easy it is with Godot Engine to whip up an OpenXR application in like just 5 minutes. For that, I'm going to introduce my co-presenter, who unfortunately could not be here with us today. So meet Bastiaan. So Bastiaan is a very experienced software engineer specializing in AR, VR, and XR. He's been deeply involved with the Godot game engine since 2017, where he started like just dumping the VR support in there. And now he's leading the XR development of Godot. He's got over 25-year experience in the ICT world, and so he will be presenting for us now how easy it is to just really create a simple application, an OpenXR application with Godot in really 5 minutes. So over to you, Bastiaan. Let me just, if I find my, yeah, here it is. All right. Over to you, Bastiaan.
We'll do a quick run through building a simple XR project using the Godot game engine. This starts by downloading the engine itself, which is a single executable download from the main website. For this demonstration, we will be using the beta of Godot 4.3, a version that should be officially released any day now. After starting Godot, we are presented with a project manager from which we can create a new project. We'll give our project a name, and we can see Godot will automatically create a folder for us. We're also presented with a choice of renderer to use. The compatibility renderer is an OpenGL-based renderer that is the recommended option when deploying to standalone XR hardware. The mobile and Forward Plus renderers are both Vulkan-based renderers. The Forward Plus renderer is our high-definition renderer that provides realistic visuals. The mobile renderer is more suitable to our XR needs, and that will be the renderer we'll use today. With our project created, we need to do a little setup. It is totally possible to quickly scratch build XR applications, and we have various tutorials and examples available. But for today's demonstration, we'll open the asset library and search for the Godot XR toolkit. We simply select it, hit download, and install it. Godot will throw a few warnings, as the plugin does not enable itself right away. Those will resolve themselves. Under the project menu, we can find the project settings. On the plugin tab, we can enable our XR Tools plugin. We go back to our General tab and scroll down until we find our XR heading. On the OpenXR tab, we simply enable OpenXR. On the Shader tab, we enable our stereoscopic shaders. Now we must save and restart our project for these changes to take effect. Godot organizes our game into scenes. We'll create our main scene by clicking on the 3D scene button. Scenes are organized in nodes, which are our building blocks. I like renaming the root node of my main scene to main. This is a good time to save our scene for the first time. Godot requires us to execute 3 lines of code to set up XR. Lucky for us, XR Tools comes with a script that does that and much more. We simply add a helper node to our scene and use the dropdown on its script property to load this script. We find it in Add-ons, Godot XR Tools, XR. The script is called startxr.gd. This script does all the setup work for various OpenXR features and also contains code that allows you to deploy your project as a WebXR project. We need a few nodes so Godot knows where our player is in the world. First, we add an XR Origin 3D node. This node maps the physical play space of the player to the virtual world. Next, we add an XR Camera 3D node. This node will automatically be positioned based on the headset tracking data OpenXR provides. But I like giving it a default location for visualization purposes. Now we'll add an XR Controller 3D node, which will track our left-hand controller. For this, we set our tracker to the left-hand tracker. This node will automatically be updated to the location of the left-hand controller, but I again like to give it a default location so it looks good in our editor. We'll create a second XR Controller 3D node and now repeat our setup for the right hand. This setup is the bare minimum that is needed to get an XR application up and running in Godot. However, if we run it right now, all we'd see is an empty world in which we can't do anything. To make our demo more interesting, we'll load in an asset that we downloaded from Sketchfab. All we've done here is add some nice pictures in the picture frames and add collision shapes for the floors and walls. To allow our player to move around this environment, we'll use a few components from our XR Tools library. We begin by adding a player body scene to our XR Origin 3D node. This node will track the player's position and ensure they do not walk through walls. Then, for our hands, we want to be able to see those. So we add scenes that bring in hand models that will react to our user's actions. Next, to allow our user to use a traditional teleport feature, we simply add the logic for that feature as a scene to our left hand. This lets the user use the left hand's trigger to teleport. On our right hand, we'll add a scene that contains all the logic that enables the player to move around with the joystick on the right hand controller. In order to turn, we add a separate scene that reacts to the same joystick. On this function, we change the configuration to smooth rotation. Note that all this setup can be altered while the game is running, so users can customize their experience. Finally, we can try out what we built. I'm using my Valve Index with Steam VR in this demo. I can look around and see my hands being tracked. And you'll see me moving around the house using the various input features we've added. This is a very whirlwind setup that only touches the surface of what you can do with Godot and OpenXR. Back to Fred, we'll show how this works together with Monado and complete the OpenXR setup end to end.
Thank you, Bastiaan.
We'll do a quick run through building a simple XR project using a Godot game.
Okay, that's enough, Bastiaan. Shut up. Now that we have an OpenXR application, let's see how how easy it is to just run that on Monado. And Monado, it will become the OpenXR runtime on any platform, right? You just go on Monado website, clone the our GitLab, clone the repo. There's like build instructions, super easy to build. And here in this demo, we'll be using Vive trackers with the index, as it was the case for Bastiaan. And it's just a matter of really 1 minute, you'll see.
We can now run Monado service. On startup, Monado will probe for connected recognized hardware and instantiate the right builders. Here, we can see that the Monado loaded the HTC Vive driver and used the Lighthouse builder to create the Valve Index head and controller devices through Ellipse Vive. Let's move that debug window on the side. And since we now have an OpenXR runtime waiting for client connections, let's execute our Godot applications. There you go. You can see that the controllers are correctly tracked. Teleport feature that we added in Godot is working as expected, and we can look around and move very naturally in the XR space that we just created. Note that you could have done the exact same thing on Windows or Android, depending on the hardware you had. We can now run.
Okay, we're ending the end of that presentation. So just to close on Monado, if we have time, yes, I think we have time. So it's interesting to use that diagram, which is like a really marketing-friendly diagram, but really far from the truth, the complexity of Monado, right? But it's going to be handy to talk about the use cases that platform developers use Monado typically with, right? So let's say you're a platform. Let's say you are a company integrating XR into products or services. Probably you're on modded hardware, maybe old hardware that does not provide OpenXR compatibility. Well, you probably want to use Monado's OpenXR state trackers and a fake compositor and just sit this on top of your platform, making the required interconnection into your APIs down there. And with relatively with a relatively painless effort, you're going to end up with having your old platform suddenly have OpenXR capabilities, thanks to Monado's very modular nature and open source nature, right? If you are, for example, if you're a robotics company interested in playing with SLAM or a stereoscopic display maker that you want to integrate hand tracking, egocentric or non-egocentric hand tracking, those are modules that are at the moment part of the Monado tree, right? So you can basically use the backbone of Monado, but just use those two modules. Start to play with that today. So you can go, it's all free, it's all open source. You can get your development team to play with those modules right now, right? Maybe you are maybe you're an Android based platform, already OpenXR, and you want to free yourself from the vendor lock-in, right? Or you want to overcome limitation that you're having right now in the underlying platform. Well, with Monado, those are the things that we do. You can basically, integrate Monado at the right level into the platform, still keep the OpenXR compatibility, but make sure that you go like kind of a hybrid Linux, Android, thus midterm freeing yourself from the vendor lock-in. So those are typical use cases that Monado's used for. Pretty neat. And so let me put my OpenXR Vice Outreach Officer hat back on to give you a glimpse of how we see the OpenXR future at Khronos. For the extension side, of course, we would like to keep consolidating even more extensions into the core spec, right? In order to make OpenXR an even more welcoming place for API, for developers. And on the feature side, well, you've seen it in AWS show floor. I mean, the industry is in constant evolution, right? And it's sparkling with new startups and it's flourishing, right? And so we would like to keep adapting to this nature. So Khronos Khronos being built by an industry for the XR industry, we're just going to keep evolving and make sure that OpenXR stays a must. And so if you're a developer interested in open source technology, especially XR technologies, please contact Khronos, get in touch. You can provide feedbacks and requirements through our GitHub, Discord. Get in touch with us. Even better, if you are considering OpenXR in your platform, consider joining the Khronos Group, any OpenXR Working Group. There are tons of information on our website how to walk the path towards OpenXR compliancy, which is kind of a codified path. So you need to contact us before. We will hold your hand into the process. And some of that requires to be a member. But you'll see, go on our website and then just try to read as much as you can. You'll see that there's a lot of benefits into becoming OpenXR compliant. And so on that, I thank you for your time.